Hello, we're looking at problem number 2 found in lesson 9-6 in your textbook. This is found on page 589 of your geometry part 2. It's asking us to find a dilation image. If we read this right here, what this is saying is it wants us to take the original triangle of PZG, which is right here, over here in the right picture, and this D sub 2 means that we want to dilate it by a scale factor of 2. Now, in order to do that, we're going to find the coordinates for each vertex, and we're simply going to take each one of those coordinates and we're going to multiply them by 2, because that's what a scale factor of 2 actually means. So if we look carefully at these three images here, the first one is at 2, -1, Z is at -2, +1, and G is at 0, -2. Those would be your image. Now, what it's trying to show you here and here and here is they're taking those coordinates. They started with P, so they're taking those coordinates, which are those and those, just like we had over in the picture, and they're multiplying each one of those by 2. So 2 times 2 is where they're getting the 4, and 2 times -1 is where they're getting -2. When they regraph that, of course, this becomes P prime right here. And then they do the same thing for Z, which was -2, 1. If you multiply each one of those, again, individually by 2, you end up with -4, 2. And then they graph that, and that becomes your Z prime. And then, of course, they do the same thing for G. The original point was 0, -2. If you take it and multiply each one of those by 2, you're still going to get 0, but then you're going to get -4. And so if you plug 0, -4 in, you get the G prime. Okay. So when you reconnect those lines, you're going to get P prime, Z prime, G prime. And that image is going to be twice as big as of course, the original image, because that's what a scale factor of 2 actually means. Okay. Now, in the got it, what are the coordinates of the vertices if you had 2 and you had a 1/2 here? Well, again, we're going to take the coordinates that we had on the original, which, as you can see here, P was 2, -1, and Z was -2, 1, and G was 0, -2. If we took each one of those and we multiplied those by 1/2, then we're going to end up with 1 and -1/2. For Z, we're going to end up with -1 and +1/2. And then for G, we're going to end up with 0, -1. We simply took each one of the original vertices coordinates and we multiplied those by 1/2, each one. And we come up with our new points, which would be P prime, Z prime, and of course G prime. Okay. Now, B says, how are PZ and P prime Z prime related? Well, if you were to regraph those on a graph and then you measured them, what you're going to find is that the P prime Z prime is going to be half of the original size. Okay, whether it's PZ or whether it's PG or whether it's the GZ. The new image, once it's graphed, is going to be half as big as the original. So that is the relationship with that. So the conjecture we can come up with is that it makes the scale factor makes the lines or the sides longer or smaller by whatever the scale factor is. And so if it's bigger than 1, of course, it's going to be a bigger side. And if the scale factor is smaller than 1, like a fraction, then the image is going to be smaller by whatever that scale factor is. And so, anyway, hope this was very helpful, and best of luck.